Good morning, guys. Good morning, everyone. I'm gonna get started here shortly. See everybody's coming in. So just kind of give you guys a little bit of a heads up. You won't be able to enable your microphone or your video for this. I will, at the end, answer any questions. If you guys have questions, you can just type that into the Q&A and I'll be able to answer those questions at the end. So the way this kind of works is we're not recording right now. So I will, once I hit record, I'll basically be starting the presentation, and then that's what, anyone who's not live, they'll be able to view this. Basically you're just gonna sit and listen or watch the training. And as I mentioned, you can do questions. You can type in questions if you think of something, and then at the end, I'll look at the Q&A and answer any of those questions. And then we've also got a little quiz or little. It's called a poll on here, but it's just 5 questions similar to the other training, the recorded training, but being that this is the first kind of live webinar where you guys will be able to interact, you can answer, should allow you to actually click on those questions or be able to answer those questions at the end. But like I said, we're not live right now. Once I click, or I'm sorry, we're not recording right now. Once I click record, then that's what everyone else will see once I click record, and that's what will be sent out. So I'm gonna wait a couple more minutes just to allow everyone to get in. As I said, we got 11 people in right now, and if you do have any questions, just type those in the Q&A, and I'll answer those at the end. You should be able to see my screen where it shows the, let's double check to make sure you guys can see that. Yeah, it should be showing the Fatal 4 construction hazards. All right, we got 13 folks here. That's a lucky number. So I'm going to go ahead and get started recording. And as I said, you guys won't be able to talk or see video of yourselves. This is a webinar. It'll be recorded and then sent out. So if for whatever reason you're not able to stay on or watch the whole thing, you can close out or log out and then just finish it up later on when it's sent out as a recording. But I am going to start recording and make sure you guys can see that. Okay, welcome everyone. This is the second training of the Zoom recorded training sessions. This training today will be on the Fatal 4 hazards in construction, which are falls, caught in between, struck by, and electrocution. So the first topic we'll talk about is fall hazards. Just kind of an overview. We'll talk about building structures, exterior construction areas, scaffolds, stairs, and ladders, and then how to prevent those falls with guardrail systems, warning lines, personal fall arrest systems, and floor covers. We're going to show, first thing, a video. I'm sure a lot of you, if you've gone through this training before, you've seen this video, but we've got some new folks. So I'll show you guys what that looks like. Oop. Bear with me for a second when I get the screen switched over. All right.
Кидай нахуй леса! Я говорю, садись, будет падать, садись в стол по-любому вот этим аппендицитом. Он повисит вот такой центральный. Я же сказал, садись в стол.
So as you can see there, I think it says at the top, Russian building demo. So that's not something that happened in this country. Not saying that, you know, things like that don't happen, but other countries, sometimes they have different, well, they either don't have a regulating agency like OSHA. So you see a lot of sketchy stuff, and there's a lot of hazardous situations in other countries. All right, next slide is on building structures. So work conditions 6 feet or 6 feet or more above a lower level require the use of fall protection. So unprotected sides, edges, leading edges, excavations, and walking and working surfaces. But regardless of height, fall protection must be used when working above dangerous equipment, sharp objects, and piercing objects. So exterior construction areas, fall from a short distance can result in serious injury, and all workers must be protected from falling into sharp materials or onto dangerous equipment, and all open excavations and pier holes must be yarded or protected. So you'll see that picture on the right. You know, those hazardous situations, we see those a lot of times on job sites where we've either got open manholes or you know, foundations, things like that get pulled up or demoed. You could have open holes where someone could be walking along and fall into or trip into. So anytime we walk up on a job site and see one of those holes, we would want to barricade it or put something over top of that to prevent someone from walking into or over that hole. So powered work platforms only use equipment that is designed for lifting personnel and suitable for the assigned task. So a couple pictures there, you see a guy on the left standing on the pallet on the front of a lift. You don't want to do that. That's not safe. It's not what that piece of equipment is meant to lift. It's not meant to lift people. It's meant to lift heavy materials. You would want to use something like on the picture on the right with a man lift with that's rated to lift folks. And if you were to fall, you're protected by your fall arrest system. You want to wear a harness and be hooked on to that with a lanyard or a self-retracting lifeline. Ladders must be inspected prior to use. Ladders must be kept in a good location and in a safe condition. All right, in a good location and in safe condition. So picture on the left, if you can store those in a Connex or a shop or a building out of the elements, that's a good place for storage. You can see one of the on the right, that was actually on one of our job sites, and that ladder looks like it had been run over by a piece of equipment, and the bottom rung, I believe, was not even connected to the ladder. So you always want to inspect your ladders and make sure they're suitable for you to use. Another portion of concern with ladders is you don't want to stand on top of the top portion of the ladder. Really, the top two rungs you don't want to stand on. But as you can see here, to get that extra foot or extra couple feet to stand just to do that one task, sometimes people will do that, and that is not safe. That ladder is not designed to withstand weight from having people stand on the top. As you can see, there's another picture. Looks like that guy's putting up some Christmas decorations, but nonetheless, just goes to show you don't want to stand on top of those ladders, because for balance reasons, and also it's not rated to withstand that much weight. Never want to straddle or sit on top of a step ladder. You can see here there's a couple pictures of ways not to be using a ladder. And make sure you always use the right equipment for the job. Whether it be a ladder, a lift, or a scaffold. A 5-gallon bucket would not be what you want to use for a step ladder, or to get that extra couple feet. You want to make sure that you're using the proper equipment. Ladders must be positioned at a safe angle to avoid potential fall hazards when climbing. Extension ladders must extend 3 feet over the landing for safe access. So you can see in the little diagram to the right, you want to have a 1-to-4 ratio. So if you had a 20-foot ladder, you would want to have that extended out about 4 feet, which would allow you to have 3 feet of access for climbing off of that ladder if you were getting onto a surface. I think the picture here shows a 16-foot structure. So you just need to plan ahead a little bit, make sure you've got enough length on your ladder to be able to get that right, that correct ratio. And there's also an app you can get on your phone. It's a NIOSH ladder selector, and it'll let you know what kind of ladder you need. It's even got a little device where you can make sure you're at the right angle, just to ensure that you're not going to tip back or fall down whenever you're setting that ladder or climbing up that ladder. So with ladders, you want to maintain contact with the ladder using both hands to keep a safe grip. You want to face the ladder when going up or down, and never climb a ladder while carrying any materials. So the main thing when you're climbing ladders, or whether it be a fixed ladder or a mobile ladder, you want to make sure you're maintaining 3 points of contact. So that's either 2 hands and 1 foot, or 2 feet and 1 hand. While you're climbing that ladder, you want to always make sure you've got at least 3 points of contact. So for preventing fall accidents, construction work performed at 6 feet or higher above a lower level requires protection. So that's a construction standard. For general industry, like our asphalt plants or our maintenance shop, it's 4 feet. Now I know that's a little confusing because different industries have different standards, and it doesn't make sense. But for that type of work, the exposure is different. So we just say 6 feet because most of the work that we're doing at our asphalt plants or at our at our maintenance shop. If it's going to be at heights, it's higher than that 4 foot rule. So we just say 6 feet across the board for our company. Some fall protection methods include guardrail systems, warning lines, fall arrest systems, and floor covers. So the fall arrest system components are your body harness, your lanyard, and an anchorage point. You can also use a self-retracting lifeline for your lanyard or your attachment. The body harness must be worn properly, and the D-ring must rest between the shoulders, and the chest strap must be secured. So you can see here a picture of the guy on the right. You got that chest strap right across right above right about the nipple area of your chest, and then the D-ring is right at the center of the back. So in case you were to fall, it's going to distribute that weight properly and not cause, hopefully, any kind of circulation issues or damage to your internal organs. A body harness must be inspected before use, adjusted to fit the worker, and free from other visible damage. So as you can see on the right, it's not adjusted. The straps were loose. D-ring is not, up in the center of the back. If you were wearing this harness and were to fall, it's probably going to cause not as much damage as if you weren't wearing the harness, but you could definitely have severe injuries from a fall if you're not wearing your harness properly. So this photo looks like this was from the state fair. This guy had his lanyard attached to the D-ring, which was on the front of, or had the harness on backwards, and then had the lanyard attached to the D-ring. So not only was he wearing the harness incorrectly, he did not have it anchored off to anything. So that's kind of pointless. All right, anchorage point is the anchorage point is the place where you tie off or hook to. Anchorage point must support the force of a falling person. And so the way OSHA dictates that they say it must be able to withstand 5,000 pounds of force per person. So you just want to make sure whatever you're anchoring off to, you've got a good anchor point, and it's basically think about if it would if you were to attach your pickup to that, would it be able to hold that that weight up? So you don't want to tie on to handrails or ladder rungs or anything like that. It needs to be something strong enough to withstand 5,000 pounds of force per person. This is on the, you don't really have much work that would have us working on top of roofs without having fall protection. But nonetheless, if you do find yourself working at heights and then there's a drop and you don't have fall protection, you can put up a temporary barrier that would prevent or not allow you to be working along that edge. You want to have that at least a 6 foot minimum. All right, next hazard of the fatal 4 hazards is caught in between. Just an overview of that. So we'll talk about cranes and heavy equipment, tools and equipment, materials handling, and trenches and excavations. And ways to prevent that would be through guarding, moving equipment and parts, barricades, proper materials handling, and shielding of trench boxes. Shielding and trench boxes. So caught-in hazards occur when a worker is caught inside of or in between different objects. You can see the picture to the right. That could definitely be a situation where you guys might be exposed to, where track hose loading looks like a little flatbed truck. You never want to get in between a fixed structure and a piece of equipment. Never place yourself between a piece of heavy equipment and an immovable object. Shows that guy getting crushed. Tools and equipment. So caught-in hazards exist when workers remove or disable guards on tools or equipment. You can see there's a skill saw with, looks like they put some sort of wedge or something in the guard to prevent it from sliding. So you don't want to do that. You never want to disable guards or remove guards on any kind of any equipment. Those guards are put on there for a reason. Never place your hands or body near moving parts. Gloves, long sleeve shirts, jewelry, or loose fitting clothing can be hazardous if caught in moving parts. Never use equipment that is missing guards or other protective devices. You can see there's an air compressor there with a pulley, and the guard is not on that. Never want to be working around equipment that doesn't have a guard. If you have, loose clothing or jewelry or long hair or something like that, you could be working around that, and it would potentially get caught up in there, and could be very dangerous. So for materials handling, use caution when handling materials. You want to properly handle and guide materials that are being flown overhead. So having a guy wire or some way to get that into position while not standing underneath of that suspended load. Be careful when stacking and storing materials. Do not place yourself between materials and an immovable structure. That's another thing. If we're positioning, pipe or equipment or different things, we don't want to put ourselves in a pinch point or in an area where if that load were to shift or drop, if it were, if you're standing downhill from something, you don't want to be in between that equipment or that material and not be able to get out of the way. So you can see on the picture there to the right, that guy's in a bad position, bad spot. He should be on the other side. And another way for accident prevention is to plan your work and look for potential hazards. So just basically doing a site walk around or just the area that you're working in, doing a little pre-task planning, doing a JHA, talking about it in your crew huddle. Because every day we go to work, we have no idea what hazards could present themselves. So when conditions change or the plan changes, we always want to take a second and talk about it with everyone, make sure we're communicating that and everybody's on the same page before we continue work. So for trenches and excavations, workers inside of an excavation must be protected from a cave-in. Workers are exposed to potential cave-ins when there are unprotected sides. So trench boxes, sloping, sometimes sheet piling. We have to use sheet piling for deeper excavations. We just want to make sure that those sides are protected. So before performing any excavation work, all employees must be trained. When excavation work is taking place, a competent person must be present. Anytime an excavation's depth is greater than 5 feet and less than 20 feet, a competent person must select the protective system to be put in place. Excavations over 20 feet require the design of a protective system by a licensed professional engineer. So typically, if we're doing deep excavation work, we'll have plans, whether it be through United Trench Safety or some other sub would design that, and that would be in the plans, and we would build that to the design plan. So just to make sure, depending on the depth and the width of the excavation, it would be able to withstand the force of the material pushing against it. Benching and sloping prevents the sides of a trench from collapsing onto workers inside of a trench. A safe way to enter and exit excavations must be provided anytime there is a trench. Regardless of the type of protection used, a safe way to enter the trench is required. So ensuring that you've even 25 feet. All right, next portion is on struck by hazards. Quick overview of that. For hazard recognition, you have struck by falling objects, struck by flying objects, struck by swinging and slipping objects, and struck by objects on ground level. And ways to prevent that would be through personal protective equipment, material storage, proper materials handling, and work zone safety. Struck by hazards exist anytime a worker could be struck or hit by an object. Working or walking below elevated work surfaces may expose you to falling objects. So this was a photo I took on Camp and Folly. We were doing the outfall control structure. I believe that little community is Oyster Point. And this was a sub working for us. And one of the guys was leaning on the ladder right over the edge. So he must have trusted that that ladder was not going to fail. And he was basically putting himself at risk and the workers below. So before I went over and told him, hey man, you don't need to do that, I snapped a quick picture. Materials being moved overhead expose you to falling objects. So picture below, you never want to work underneath a suspended load. Want to store materials properly. Make sure if you do have to stack and store materials, it's on stable ground, it's on level ground, and ensure that no one will be working underneath of that, and it's in a safe area. Power tools and activities such as pushing, pulling, or prying can create flying objects. Grinding or striking materials can create flying object hazards. Do not work under loads as they are being lifted. So like I mentioned before, if you do need to position or move that material, make sure you've got a guy wire or some other way to get that material into position without exposing your hands, your feet, or your body underneath of that load. Heavy equipment can create serious struck by hazards. So you can see on the picture to the right, they're digging an excavation, and not only is that excavation not protected, you can see the guy down in the trench. The operator is standing up, operating that equipment. That's something you never want to do. You always want to operate equipment from the operator's seat. He is in the cab, but you always want to be in a position where you have control of that equipment, because you never know if you make a sudden movement or go to sit down and your hand or your leg bumps a control, that could cause that equipment to crush or strike not only other structures, but also people that are working in the area. So all traffic on construction sites can create struck by hazards. Make sure you wear safety glasses and a face shield if flying hazards exist. Secure materials so that they do not fall on workers. Maintain proper housekeeping in all storage areas. Okay, the fourth and final hazard that we'll be talking about today is electrical hazards. So the primary causes of electrocution fatalities: contact with overhead power lines, contact with live circuits and panels, poorly maintained cords and tools, lightning strikes, and not following lockout tagout procedures. So the leading causes of electrical accidents: drilling and cutting through cables, using defective tools, cables, and equipment, failure to maintain a clearance distance of 10 feet. We'll talk a little bit about clearance distances in the next couple slides, but 10 feet is the most standard. The higher the voltage, the more clearance you need, but we'll talk about that in a second. Failure to de-energize circuits and following lockout tagout procedures, failure to guard live parts from accidental worker contact, unqualified employees working with electricity, improper installation and use of temporary electrical systems and equipment, bypassing electrical protective devices, and not using GFCI ground fault circuit interrupter devices, or missing ground prongs on extension cords. So just something you want to do if you're using, power tools, electric tools, any extension cords, you want to make sure all of those prongs are there. If it's got a missing ground prong, or it's bent or broken, or there's a cut in the cord, we want to take that out of service and not continue using that and get it replaced. So you want to take electricity seriously. Electricity is the second leading cause of death in construction. Electrocutions make up 12% of construction fatalities annually. Over 30,000 non-fatal shocks occur each year. We had a non-fatal shock on HLT last year. Fortunately, it was a subcontractor. They were unplugging a pump, and that pump had been basically repaired and was not properly, they didn't make the repair properly. So there was an exposed wire. It had been raining, and when he grabbed the hold of the cord and went to unplug it, it shocked him. But fortunately, minor first aid incident, and he was okay. But nonetheless, there is a large frequency of non-fatal shocks that occur each year in construction. And there's over 600 deaths occurring annually due to electrocution. So the hazards of electricity, you've got shock, which is the most common and can cause electrocution or muscle contraction, leading to secondary injury, which includes falls. Fires, enough heat or sparks can ignite combustible materials. Explosions, which electrical spark can ignite vapors in the air. Arc flash, which can cause burns ranging from 14,000 degrees Fahrenheit to 35,000 degrees Fahrenheit. And arc blast, which is in a short circuit event, copper can expand 67,000 times. The expansion causes a pressure wave, and air also expands, adding to the pressure wave. We had an arc blast event on HLT, a subcontractor. Nothing they did wrong. They followed their procedures, and no one was injured. But the provider, where the service was coming in, was sending in too many volts. So that's what caused the arc blast event. It wasn't due to a tool or something being in that transformer box, or dust buildup or anything like that. It was just a rare event that could not have been prevented unless we had known the voltage that the provider was sending into the facility. All right, we're going to talk a little bit about overhead and underground power lines. That's a big exposure for us. We've had several underground utility strikes and several overhead power line strikes with our asphalt trucks, with the beds being up. So this is a good topic to discuss. So some background on power lines, hazards of overhead and underground power lines, injury prevention techniques, and a summary. So just a background, power lines transmit electricity. Electrical current exposes workers to serious hazards. Most common hazard is electrocution. Most workers are unaware of the potential electrical hazards. Power lines can be overhead or underground. Some activities may cause interference with power lines. Overhead power lines, operation of a crane, forklift, or other construction equipment changing street lights, tree trimming, and for underground power lines, you've got excavation. So there's a lot of exposure in our industry, specific to excavation work, or if we're putting in pipe, or moving across job sites, and not having locates, not having proper locates. And even if we do have it located, you never know when there could be a line that's not, on the plans, or sometimes those locates are not as accurate as we think they are. So you never want to assume anything when you're excavating near underground utilities or live lines. So types of electrical lines, you got electrical cables, which are high voltage and low voltage, and supervisory and signaling cables, and then communication cables, which are phone lines, coaxial cables, and broadband cables. So who's at risk? Almost everyone working near power lines. Some common hazards are electrocution, injuries which are typically fatal, electrical shock, fires, and falls, which are a result of contact with the electricity. So when we're unloading materials, we want to watch out for overhead power lines, and there could potentially be a fire after an overhead power line is hit. So some common misconceptions: birds land on power lines, so they must be safe to touch. That's not correct. The main objective of electricity is to reach the ground by using the most direct route. Birds do not get electrocuted when they land on wires, because they do not represent a path to the ground. Power lines are safe for perching, but not when struck. Power lines are insulated, so they are safe to touch. That's not correct. They are not always insulated. Insulation deals with placing non-conductive material around the wire. Insulation is a material that offers high electricity resistance, making it suitable for covering wires to prevent the possible future contact of adjacent conductors, resulting in a short circuit. Just because a wire is weather protected does not mean that it is insulated. Weather protection prevents from water and snow from reaching the wire, and insulation if used. Non-metallic ladders are safe around power lines. No, that is not correct. Wet ladders can be a conducting medium for electricity. If power lines are touched, they are safe. That is also not correct. Electricity can jump. That's why we want to maintain a safe distance from the danger zone, which OSHA's rule is a 10-foot radius from the power line, but we'll talk about that in a second. Conducting site investigation to identify existing conditions of voltages of lines and equipment, presence of hazardous introduced voltages, presence and condition of protective grounds and equipment, grounding conductors, locations of electrical circuits and equipment, and maximum switching transient voltages. So dump truck operators should use caution when unloading materials near overhead power lines, which I know whenever when drivers are dumping into the paver or the shuttle buggy, we've got spotters to guide them in and get them pulled away. But a lot of times when drivers go to clean out on some job sites, they'll drive with their beds up. They should not be doing that. They should lower their bed and get to the area where they need to clean out, and then re-raise their bed. You never want to drive across the job site with your bed up, because you never know where power lines might be. So some injury prevention techniques: you want to stay away from power lines when working, maintain safe distance. OSHA's 10-foot circle of safety rule, but you want to increase the safe distance near higher voltage power lines. So here's a chart for operation clearances for energized overhead power lines. So like I said, OSHA's got, a 10-foot rule, but depending on the voltage, it could be, you could need to have a little bit farther clearance distance. So just to kind of let you know, so the transmission lines over the Charleston plant, those are 115,000 volts. So for that, we would want to have a 15-foot clearance, and then the transmission lines over the Somerville plant are 23,000 volts. So we should be good with that 10-foot clearance rule. You want to recognize high voltage power lines. If unknown, the appropriate agency should be contacted. So if you don't know what the voltage is, you would want to check with the provider. And then inform others about high voltage power lines. Something we started a few years ago, job sites that were on long-term, we'll put up overhead power line signs just as a heads up to if you're driving underneath of that with equipment or vehicles that are, a little higher, or if you are driving under them while we're paving, we want to make sure we give some advance warning to let folks know, hey, you're going under a power line. So any job sites that we're on, those signs are available. We can get those put up. You want to examine the site. Be mindful of power lines. Search carefully around the site and look for lines not seen due to obstructions. Alert others at the pre-job briefing and assume all lines are energized and potentially dangerous. Make a safety clearance boundary and have portable safety barriers. So this is at, looks like the Somerville plant, where some material, whenever we're loading material or offloading material, sometimes those piles, they get large and we don't realize that they're piling up or spilling over onto power lines. So just goes to show you, that you always want to just walk around and make sure you're inspecting your job site, where you're loading materials, offloading materials, and make sure that it's not interfering with any power lines or guy wires for those lines. So for injury prevention, you can use a spotter. Equipment operators have limited visibility. You want to get the spotter's help to stay clear of overhead power lines. The spotter's job should only require spotting and not guiding. Guiders may be at risk of electrical shock, so be careful, especially when you're using a tag line. When working with tall and long equipment, carefully plan and organize work with heavy equipment. Keep vehicles clear of power lines and watch out for long objects. Adjust the position of the equipment to maintain a safe distance from power lines. In cases of fallen power lines, stay away, call for help, shuffle with your feet together on the ground to minimize electrical shock, and encourage others to do the same. So there have been cases on job sites where we'll have down lines, and if you're working in that area, you would want to keep your feet together and shuffle at a minimum 50 feet away from where that line is, and not touch any equipment or any metal until that line has been verified that the power has been shut off to it. You just want to, now if you're on a piece of equipment and there's a power line on it, unless that vehicle or equipment is on fire, just stay on it. You don't want to take a chance and jump off if it's not on fire. If it is on fire, however, you would want to get off of there, but make sure when you jump, you keep your feet together and then shuffle your feet till you get about 50 feet away. Fallen power lines can cause fires. If a coworker makes contact with the power line, stay away. You want to protect yourself. You could be shot too if you touch someone who is in contact with electricity. If you hit a power line, in the case of no imminent danger, move the equipment away. Have someone call 911 and stay on the equipment until you know it's safe. Warn others to stay away. If you must get off the equipment, jump clear. There's a photo. Fortunately, that was a communication line, but nonetheless, you never want to assume that line is not carrying voltage or it's not energized. You'd want to stay in that piece of equipment or that vehicle until you can verify that line is dead. So you would want to assume all overhead lines are carrying electricity. Break contact with the overhead line if you can. If you can safely back away from the line, move at least 30 feet away from it. If you cannot back away safely from the line, stay put. Do not exit the vehicle or attempt to move the line yourself. This can result in electrocution. Call 911 and wait in your vehicle or equipment until authorities arrive and the scene is secured. If there are workers on foot nearby, instruct them to move at least 30 feet away. If you must exit due to imminent danger from fire, jump away from the cab and shuffle and hop with both of your feet to a distance of at least 30 feet. Do not step. So hitting buried power, gas, or communication line can also cause injury and be an excessive cost of repair. Plan the work ahead and call the utility company. With proper planning, these types of events, mistakes can be avoided. So locate and mark the perimeter of underground lines. Exercise caution when excavating near power lines. Some manual excavation may be required, and stay away from the pad mount transformers, the green metal boxes. All right. So if you guys have any questions, you can ask those. And I am going to open up the poll. So I'm going to leave that up for a couple minutes and then we will discuss those in a moment. I'm going to look and see if we got any questions. We'll leave up the quiz for one more minute. So if you guys go into that and answer those questions, we'll discuss them here in about a minute. All right, looks like everyone has answered, so we'll go over this real quick. So, which is not a method of protection for preventing a cave-in from the sides of a trench? So, is it benching, hoisting, trench box, or sloping? Looks like 8 of 9 people guessed hoisting, and that is the correct answer. Number 2, when climbing a ladder, always maintain how many points of contact? Is it 1, 2, 3, or 4? And 9 of 9 answered 3, and that is the correct answer. Number 3, shock is the most common hazard of electricity. True or false? Looks like we got 9 out of 9 on that one, and it is true. That is right. Good job. Number 4, what hazard causes the most fatalities in the construction industry? Is it caught in between, electrical, falls, or struck by? So we were a little bit all over the board on that one. 5 of 9 guessed falls, and that is the correct answer. Falls are the leading cause of most fatalities in the construction industry. And the last one, number 5, when are you exposed to being struck by falling objects? Is it at the end of the day, right before the sun goes down, while working or walking below elevated work surfaces, whenever your supervisor isn't around, or in the summer when the temperature exceeds 100 degrees Fahrenheit? And the answer is, got 9 out of 9 for walking or working below elevated work surfaces. All right, guys. I appreciate that you joined today, and we will see you soon. See you guys. Thanks.